Perfect. Like Nathan said, my name is Anthony Wilkes. I'm with Life and Safety Consultants, and today we're going to talk a little bit about respirable crystalline silica. So our objective today is, of course, to describe silica and the hazards associated with silica. We're going to review OSHA's respirable crystalline silica standard, and then we're going to discuss that respirable, the RCS NEP that OSHA put out, okay, in 2020. So what is silica, right? Of course, crystalline silica is a mineral found in many materials. It's found in stone, rock, concrete, brick, block, and mortar. And that's the most common uses that we know of, right? Industrial processes on these materials can cause workers to be exposed to small silica dust particles from cutting, sawing, grinding, sanding, crushing, and drilling. Exposure to RCS can also occur during the manufacture of products such as glass, pottery, ceramics, bricks, concrete, countertops, and artificial stone. So in particular, silica exposure during the fabrication of artificial stone countertops is an emerging hazard that has been associated with outbreaks of severe accelerated silicosis in the U.S. And we'll talk a little bit about it. I mentioned it again later on, but OSHA is really targeting that industry. Additionally, fine industrial sand used in industry can also be a source of RCS exposures, such as in certain foundry operations, and increasingly in recent years during the hydraulic fracturing, which we call fracking now. So the hazards of silica, of course, the small silica dust particles are often called respirable crystalline silica. These particles are small enough to travel into a worker's lungs, right? These particles are at least 100 times smaller than ordinary sand. Once respirable crystalline silica reaches a worker's lungs, it can cause silicosis, which is an incurable lung disease that can lead to disability and death, lung cancer. Of course, it can cause COPD and kidney disease. Oftentimes, though, it takes years of exposure to RCS for these diseases to manifest. So most of the times, the employees or individuals exposed to this may not see some of these diseases to 10, 15, up to 20 years down the road. A little bit about the OSHA standard. OSHA published its final rule on the new silica standard in March 25, 2016. The construction standard 1926-1153 became enforceable on October the 23rd, 2017. And for general industry and maritime, it became enforceable on January the 23rd, 2018. During that time, also in 2020, OSHA put out a compliance directive that came out in June of 2020. And the compliance directive was given, it gives the direction to the compliance officers as to how to conduct those inspections and silica inspections, and also what are the requirements for the standard. Under the standard, there are some scope and application, some exclusions. The exclusion applies only where exposures below 25 micrograms per cubic meter for an 8-hour time weighted average are expected or achieved without the use of controls. That's key, without the use of controls. An employee would not be exempt from the standard on the basis of exposures below 25 micrograms per cubic meter when the ventilation or containment system is used. OSHA considers the failure of those controls to be a foreseeable condition, and the employer will not be exempt on the basis of the data showing that exposures are below that 25 micrograms per cubic meter. The construction standard is a little bit different from the general industry and maritime standard. In particular, the construction standard has this table 1 where it talks about specified exposure control methods. If table 1 is followed, employers are required to fully and properly implement the engineering controls, work practice, and respiratory protection set forth for the relevant task in table 1. So table 1, we'll look at that a little bit later. It talks about particular tasks. Employers that fully and properly implement controls according to table 1 are not required to, 1, conduct an exposure assessment for employees engaged in those tasks, and demonstrate compliance with the PEL. Make sure you review the elements of the tool manufacturer's instructions relating to airborne dust emissions. Again, where the employee has fully and properly implemented the engineering controls, work practice, and respiratory protections in table 1, then there's no PEL violation and do not have to assess exposure of employees engaged in the task. Now, if the employer has not fully and properly implemented controls as specified on table 1, the employee must be in compliance with 1926 1153D, which is alternative exposure control methods. And that's where they have to conduct sampling as necessary to determine employee exposures at or above the action level, or have they exceeded the permissible exposure limit. And here's what table 1 looks like in the construction standard. In table 1, you have an equipment or task, and then the next column will be about engineering and work practice controls. And then the last column talks about the required respiratory protection and the minimum assigned protection factor for the type of respiratory. If you are following this in construction, you have to follow this exactly like it is. You have to fully implement this. And there's one example we have, it talks about handheld power saws. So you use the saw equipment with the integrated water delivery system that continuously feeds the water to the blade. So it's a water system. When it's used outside, if you look over the respiratory protection, if you're less than 4 hours for that shift, you don't have to have any respiratory protection. But if you over 4 hours for that shift, you need a respirator with APF of 10, which is basically a dust mask. And then when it's used indoors or in an enclosed area, for both, if you less than 4 hours or greater than 4 hours, you need to use respiratory protection with an APF of 10. And then, of course, it says operated and maintain the tool in accordance with the manufacturer's instructions to minimize dust emissions. Now, under those, if you have to use those alternative measures, there are 2 options. And these options are good for general industry, maritime, and construction. So doing those exposure assessments, the first option is that performance option. And this must assess before the work begins. And then you can use any combination of air monitoring data or objective data. Okay. Now, the other option is those scheduled monitoring. And that's the option most employers use, scheduled monitoring. And they must assess as soon as work begins. And if the monitoring indicates the initial exposure to be below the action level, no additional monitoring is required. If it's greater than the actual level, but less than the PEL, you repeat that within 6 months. And if it's above the PEL, you have to repeat that every 3 months. Now, to get out of monitoring, there's some other monitoring is required to discontinue with the monitoring or when the circumstances change. And so reassessment must be conducted whenever a change in production, process, control equipment, personnel, or work practices may reasonably be expected to result in new or additional exposures at or above the action level. That's 1. Or 2, when the employee has any reason to believe that new or additional exposures at or above the action level have occurred. And then also reassessment would not be required if a personnel change is made that is not expected to impact the magnitude of employee exposure to silica. I wanted to talk a little bit about objective data because we get a lot of questions about what is objective data. and once you look at this, you see why most employers use the schedule monitoring option. Objective data includes air monitoring data from industry-wide surveys. It could be data provided by equipment manufacturers, trade or professional associations, or calculations based on the composition of a substance. But this is the hard part. It must demonstrate the employee exposure associated with a particular product or material or a specific process, task, or activity. So sometimes there's industry-wide data, but it may not be the exact product, or it may not be the exact process that your employees may be exposed to. And it must reflect those workplace conditions closely resembling or with a high exposure potential than the processes, types of material, control methods, work practice, and environmental conditions in employers' current operations. Regulated areas. A regulated area is required if one or more employees will enter the area long enough to reasonably expect their 8-hour time weighted average to exceed the permissible exposure limit. A regulated area is not needed if an employer has and adequately enforces work rules precluding employees from entering a particular area, and if the employer has and enforces work rules limiting employees' time in the area, and the area does not have to be designed as a regulated area. So to how to do that, sometimes you have to mark the area off, post warning signs also. As far as construction, there's no requirements for a regulated area, but there needs to be procedures to restrict access when necessary. And you can handle that under the exposure control plan. So some methods of compliance. If employer exposures are above the permissible exposure limit, but the employer can demonstrate it has implemented all feasible engineering and work practice controls, then the employer is in compliance with that engineering and work practice controls part of the standard. Okay. Some other methods of compliance, if you get over that action level, or can be over that action level without the use of controls, you need to implement a written exposure control plan. The ECP must provide a description of all tasks that expose employees to RCS, a description of engineering controls, work practice, and respiratory protection use to limit employee exposures, a description of housekeeping measures used to limit employee exposures. When cleaning up silica dust, dry sweeping, brushing is prohibited unless wet sweeping, HEPA filter vacuuming, or other methods are not feasible. Also, compressed air to clean clothing or equipment is prohibited unless used in conjunction with a ventilation system that effectively captures the dust cloud, or unless no alternative methods is feasible. The standard does not prohibit the use of compressed air for purposes of operating a pneumatic tool. Okay. Medical surveillance is required for employees exposed to RCS at or above the action level. The examination shall consist of a medical and work history with employees on past, present, and anticipated exposure to RCS, any history of respiratory system dysfunction, history of TB, and a smoking status and history. Also, a physical examination with special emphasis on the respiratory system to include a chest x-ray, a pulmonary function test, of course, and also testing for tuberculosis infection. And then also any other test deemed appropriate by the licensed healthcare professional. Communication of the hazard, it applies to all employees covered by the standard. So they must review the employer's hazard communication program, ensure labels and SDSs are available, inquire from employees that engineering controls, work practices are used, and observe whether employees can demonstrate how to operate, maintain controls, on the equipment they use. Now we'll talk a little bit about the National Emphasis Program that is in place. The National Emphasis Program was established to, of course, to enforce the 2016 Silica standards. OSHA wanted to target the industries with the greatest number of exposed workers. One of the goals are to reduce or eliminate worker exposure to RCS. And OSHA is the plan to conduct at least 2% of the inspections are related to the NEP for silica. And it's also required that state plans adopt this National Emphasis Program. Okay. Why revised NEP? So, a little history about it is April 2019 analysis conducted by OSHA reviewed all of the chemical air samples collected by the agency between 2008 and 2017. And they found that 14% of the personal air samplings for silica exceeded the applicable PEA, permissible exposure limit, whereas only 2.5% of all the other chemicals overall exceeded the relevant PEA. So over the first year, OSHA began enforcing the new permissible exposure limit for silica. The agency's air sampling data showed that almost 18% of the silica samples exceeded the new PEA, whereas only about 3% of all chemicals exceeded relevant PEA. So then they also looked at the data reported by the CDC. It demonstrated that the hazardous silica exposures are continuing to occur in the industry doing hydraulic fracking of gas and oil wells and among workers who fabricate and install engineered stone countertops. Because occupational exposure to silica continue to pose a significant risk to a large population of workers, and because OSHA sampling data continue to show a high rate of non-compliance, OSHA determined that the NEP is warranted. And the NEP will aid in OSHA efforts to address workplace exposure to silica. So the OSHA said they're going to target those high-risk industries. And then they also estimated that there was almost over a million workers exposed to silica above the new PEA. So what industries are targeted? So what OSHA decided to do was focus on the top 500,000 of the highest exposed workers, where they looked at the sampling data and the exposures were greater than or equal to twice the PEA. So we're talking about workers that had the potential to be exposed to at least 100 micrograms per cubic meter. And OSHA looked at the construction workers. They estimated that there was over 500,000 workers in construction that may be exposed to twice the PEA. And they looked at all the data and they list out some of the top 10 top industry codes. But some of those construction activities include abrasive blasting, drywall finishing, heavy equipment operators, concrete and masonry, drilling, and jackhammering. But OSHA also looked at the general industry and maritime workers, and there were OSHA estimated there were over 50,000 workers that could be exposed twice the PL in those industries. And they looked at the top 30 industry codes. And all of these codes are listed in Appendix A of that National Emphasis Programs. But some of those industries for general industry is you got asphalt shingle manufacturing, you got ready-mix concrete manufacturing, you got clay building manufacturing, that's one brick manufacturing, you got concrete block manufacturing, and then cut and stone product manufacturing. And in particular, OSHA put out a memo for their offices to conduct particular inspections in their cut stone and stone product manufacturing. So that's your granite marble manufacturers. And also, OSHA estimated that there were over 30,000 workers in electric power and in state and local government construction that were exposed to silica as more than twice the pill. So since the OSHA standard came into effect in 2016, here are some of the top 5 cited standards in general industry. So number 1 is that 1910-1053 D1, and that's that employee exposure assessments. So that's where employers must conduct those exposure assessments. The second one is 1910-1053 F2I. That's that written exposure control plan. So the standard requires if your employees are exposed to silica, you need to develop a written exposure control plan to reduce their exposures. 1910-1053 C is the permissible exposure limit. And then number 4 is the over engineering and work practice controls. And number 5 is medical surveillance. And it kind of mirrors the same thing for the top 5 construction silica standards cited. Number 1 is that table 1, construction employers are not following table 1 exactly like it says. 2, employee exposure assessment. Of course, that written exposure control plan has communication and respiratory protection. Nathan, that's all I have for this.
No, that was fantastic. That was great. Good, really good information. Keep the screen up on for just a minute. I've got a couple questions. One of the questions was, where can we find table 1? I don't know if any of you noticed, but I did put into the chat window, there's a link where you can click and it'll take you to OSHA's table 1 page that lists out all of the different types of equipment, exposure levels, the stuff that would be required for that. So I already answered that one. Another question. Back when Life and Safety started doing this, we developed a respirable crystalline silica competent person training. Is having a competent person still a requirement as part of the OSHA requirements?
Well, you have to have someone that's knowledgeable of the silica exposures and the exposure control plan. So that's what you need, somebody knowledgeable in, to make sure that somebody can develop that exposure control plan and who can implement that exposure control plan, and then understand when the hazards change as to how to mitigate those hazards.
So a competent person is still required. And I know, remind me, with a construction site or a construction type business, isn't there a requirement for like a certain number of competent people per employees or per location? Like a competent person has to be on site. Is that correct?
I have to look that one up, Nathan, as to exactly how it's worded.
Gotcha. Okay.
But I can, if you give me who that is, I can answer that question later.
Okay. All right. Well, I will go ahead and do that. Those are the questions we added. Just shameless upsell. If anyone does need to have competent person training for respirable crystalline silica, we do offer that online. So feel free to email me or just email info@Life and Safety, and we can get back to you on what that would cost. Or you can go to our website. It's on there too.